Hi, I am meteorologist Kyle Perez with the National Weather Service in Springfield, Missouri. As part of the Weather Unlocked video series, we will be taking an in-depth look at satellites and how the NWS uses satellites on daily operations. So let's begin with the types of weather satellites. To begin, you have your polar orbiting satellites, or better known as polar orbiting environmental satellites, POES. They typically orbit at around 500 miles above the Earth's surface and observe the same spot on Earth twice daily, once during the daylight and once at night. The other type of weather satellites are known as geostationary, or geostationary orbiting environmental satellites, GOES. They typically orbit at around 22,300 miles above the Earth's surface, and they spin at the same rate of the Earth and are constantly focused on the same areas. Over the next few slides, we'll take a closer look at some of the POES and GOES satellites. So let's start off with POES satellites. The POES satellites use instruments on the satellite to gather measurements of various things, including the conditions of the atmosphere, ocean, and on land. Some of these measurements and observations include land and sea surface temperatures, rainfall rates, snow and ice cover, fire location, smoke plumes, temperatures in the atmosphere, water vapor, and pollutants. As part of the JPSS series, or the Joint Polar Satellite System, this consists of 5 polar orbiting satellites with 4 or more instruments. Here's a look on the right at what the JPSS series looks like. While the latter 3 that are shaded here in blue, JPSS 2, 3, and 4 are still to be launched here in the near future over the next 5 to 10 years. Looking at GOES satellites, here is a look at the current GOES West and GOES East satellites. Remember that they are constantly looking over the same areas. So as you can see here, by the shaded colors on the right-hand image, that the GOES West is generally covering portions of North America into portions of the Pacific Ocean, while GOES East also covers portions of America into portions of the Atlantic Ocean. GOES satellites provide continuous imagery and atmospheric measurements of the Earth's western hemisphere, total lightning data, space weather monitoring to provide critical atmospheric, hydraulic, oceanic, climate, solar, and space data. The GOES satellite imagery ranges from captures every 5 to 15 minutes and even up to 1 minute satellite data. Here's a look at some of the different instruments that are on a GOES satellite. We will just be focusing on the GLM and the ABI over the next couple of slides and how they are utilized by the NWS in daily operations. So to begin, the GOES satellite ABI, which is known as Advanced Baseline Imager, is essentially what captures all our different wavelengths, or also known as satellite bands. Here's the 16 different satellite bands that are captured by the ABI. You have 2 visible bands, then you have 5 near-infrared bands, followed by 3 water vapor bands, and lastly, you have 6 infrared bands. So looking at that on you're absorbed by the atmosphere with regards to light, you can see that the visible spectrum begins here with our channels 1 through 2, and on the bottom you can follow how that goes all the way towards the infrared stage in your ladder channels as you approach your anywhere from satellite channels 6 through 16. So based off of previous GOES bands and GOES satellites, you can see that there was not nearly the selection that there is with the new ABI band selection with 16 different channels. The other instrument that is often utilized by the NWS is the GOES Satellite Geostationary Lightning Mapper, or GLM. So the GLM instrument is a single-channel near-infrared optical detector that can detect the momentary changes an optical scene, indicating the presence of lightning. GLM is the first operational lightning mapper flown in the geostationary orbit. The right-hand image here shows you what a GLM product looks like for a forecaster when analyzing thunderstorms over the area. For this example, you can see that the GLM, represented by the blue pixels here, represents where lightning is occurring. Here's another example of lightning being captured by the GLM instrument across portions of the southeast United States. There's also additional GOES satellite imagery products that are used by the NWS. These include derived products, channel difference products, and RGB composites. So how does the NWS use satellites? This image here shows all the different satellites that hover over portions of Earth. You have your polar orbiting ones here near the red lines, and remember those are rotating with the Earth and rotating twice daily across the entire world, while your blue line here represents your geostationary orbits. So how do we use the satellites in the NWS? There's various operations and things that we use them for, such as fires, floods, storms, even as can be utilized for rescues to relay distress signals and detect various signals across the United States on a daily basis. Wrapping up here, we'll take a look at some different questions that are often asked with regards to satellites. The first one being, why don't satellites fall out of the sky? Well, the reason that satellites don't fall from the sky is because they're orbiting Earth. Even when satellites are thousands of miles away, Earth's gravity still tugs on them. So gravity, combined with the satellite's momentum from its launch into space, causes the satellite to go into orbit above Earth instead of falling back down to the ground. Why do satellites have different orbits? The satellites have different orbits because their orbits depend on what each satellite is designed to accomplish. As we mentioned during this presentation, that there is both POES, the polar orbiting, and GOES satellites, which are your geostationary orbiting. How do weather satellites take pictures of Earth? One of 6 instruments on these weather satellites is the Advanced Baseline Imager. This imager captures 16 different images at a time of the same scene. So to do this, it separates the light from the scene into 6 different slices, or wavelengths, and commonly are referred to as the bands or channels. Some additional resources, if you would like to follow up on more information on satellites, are given here. Lastly, a reminder that if you're interested in becoming a Weather Ready Nation ambassador, to apply at weather.gov/WRN/ambassadors. Join the community and become a Weather Ready Nation ambassador today.